Welcome to the Department of Electronics and Communication Engineering. Course title that we are going to discuss is Digital Electronics and Logic Design. The course code for this is ECE 313T and the semester is third. The various contents that we are going to discuss in this are interconversion of number systems. The first interconversion is any number system to decimal number system. Another is decimal number system to any other number system. The third is binary to octal. The fourth is octal to binary, binary to hex, hex to binary, hex to octal, and octal to hex. Any number system to decimal number system. To convert any number system to decimal number system, first we have to find the weight associated with for each of the digits. Say for example, we have a number A3, A2, A1, A0, A minus 1, A minus 2. First we have to find the weight associated with each digit. The weight associated with each digit is, for example, the weight associated with A0 is r raised to power 0, and after that the powers go on increasing from r raised to power minus 1, r raised to power 1, r raised to power 2, r raised to power 3. So A3 is multiplied by R3, A2 by R2. Similarly, for the fractional part, we multiplied A minus 1 with r raised to power minus 1, A minus 2 with r raised to power minus 2. And then we add all these numbers to get the desired result. For example, if we have a binary number 11001, we have to convert it into decimal. The weight associated with each digit is 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4. So we multiply the digits 11001 with their corresponding weights and then add all the values. The resultant is 25. So 11001 in binary, if we convert it into decimal, is 25. So another example is 111011. There are 7 digits, so the weight associated with the first digit is 2 raised to power 2, 2 raised to power 1, and so on. The weights go on increasing to 2 raised to power 6. These weights are these digits are multiplied by the corresponding weights associated with them, and then these are added. The resultant is 123. In another example is 1101.01 in binary. So the weights associated with the various digits are 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3 for the integer part, and 2 raised to power minus 1, 2 raised to power minus 2 for the fractional part. And then these weights are multiplied by the corresponding bits, and then these are added, and the resultant is 13.25. Another conversion is decimal number system to any other number system. For converting decimal number to any other number system, first we divide the decimal number by the base in which it is to be converted. Say for example, we have to convert 25 to binary. We divide the decimal number by the base. So we divide 25 by 2, and we note the quotient and the remainder. We keep a track of all the remainders. After that, this quotient 6 is again divided by the remainder 2. This quotient 6 is divided by the base 2, and the quotient is 3, and the remainder is 0. So we repeat this process until we get the quotient of 0, and we keep a track of the remainder. So to get the desired base number, we write the remainders in the reverse order, that is 11001, where 1 is the most significant bit and the last one is the least significant bit. Now if we have to convert the fractional part 0.6875 decimal number to binary, as in we did in the integer part, we divided the number by the base 2, but here we multiply the number by the base 2. Say for example, 0.6875 is multiplied by 2, and the integer part here is 1, and the fractional part is 0.3750, and we note the coefficient a minus 1, which is equal to 1. Again we multiply this fraction 0.3750 by the base 2. Integer is 1, integer is 0, fraction is 0.7500, and the coefficient is 0. So we repeat this the number of iterations till the fractional part is 0, or we repeat the iterations till 2 to 3 times, and we write the coefficients from top to bottom. So the value of 0.6875 is 0.1011. Now in another example, we have 162.375. For this has integer part as well as the fractional part. For the integer part, we divide it by the base 2, keeping a track of the remainders, and starting from downwards to upwards direction, Whereas for the fractional part, we multiply the base 2 and keep a track of the coefficients, and starting from top to bottom we write the coefficients. Now if we have a decimal number 590 and we have to convert it into hexadecimal, so we divide this decimal number 590 by the base 16, which is for the hex. So the quotient is 36 and the result and the remainder is 14, but 14 in binary is written as E. Again we divide the 36 by 16, the result is 2 and the remainder is 4. We divide this 2 again by 16, the quotient is 0 and the remainder is 2. So 590 in decimal, the 590, the decimal number in hex is equal to 24E. Now if we have to convert a binary number to octal number, say for example we have this given number, which is this binary number is to be converted to octal. So we have the integer part, we have the fractional part. So to convert binary to octal, we make pairs of 3 bits. Starting from, for the integer part, we start from the right side and we make groups of 3 bits. For the fractional part, we start from the left and make groups of 3 bits. After that, when we make these groups of 3 bits, we replace each of these 3-bit binary numbers by its octal equivalent. Say 011 in octal is 3, 101 in octal is 5, similarly 10 in octal is 2, similarly for the fractional part 100 is 4. So this binary number is equal to 26153.7460. Now if we have vice versa, we have to convert octal to binary number. Say for example we have 673.12, we simply write each digit in terms of its equivalent 3-bit binary sequence. Now if we have number 673.12, the binary equivalent of this 6 is 110. The 3-bit binary sequence for 7 is 111, 3 is 011, for 1 is again is 001 and 2 is 010. So 673.12 in binary is equal to 110.00110. Now if we have to convert binary to hex, as we did in binary to octal, we made groups of 3 bits, but here we will make groups of 4 bits at a time, groups of 4 bits. So this is the integer part, this is the fractional part. For the integer part, we will start from right and make groups of 4 bits. So the first group is 1011, which in hex is equal to B. After that the next group is 0110, which in hex is equal to 4. For the fractional part, the first group is 0010, which in hex is equal to 2, and the next group is 1100, which in hex is equal to C. If we have this binary number, this is to be converted into hex. So we will start making groups of 4 bits for the integer part from right and for the fractional part from the left. So this is equal to 2C6B.F2. Now if we have another binary number, it is to be converted into hex. So starting from the right, we make groups of 4 bits. So first group is 0101, which in hex is equal to 5. The next group is 1111, which in hex is equal to F. And the last group is 1001, which in hex is equal to 9. Now if we have to convert hex to binary, vice versa, as we did in octal to binary, we represented each digit as 3-bit binary sequence. Here we represent each bit as 4-bit binary sequence. So 2 is represented as 0010, 6 as 0110, 1 as 0010, 3 as 0011, and 5 as 0101. So if we have another hex number, say 29B, we have to convert it into binary. We represent this 2 as 4-bit binary sequence, 0010, 9 as 1001, and B as 1011. Now if we have to convert hex to octal, there are 2 steps. First, to convert hex to octal, we have to first convert hex to binary and then binary to octal. For example, if we have a number 7FD6, this is hex number and this is to be converted into octal. So for converting hex to binary, we will write each digit, since this is a hex number, we will write each digit in terms of 4 bits. So 7 is written as 0111, F as 1111, D as 1101, and 6 as 0110. So this is the binary equivalent of this hex number. After that, this binary number is to be converted into octals. So we will start from right and make groups of 3 bits. The first group will be 110, the next group is 010, third is 111, the next is 111, and again the last is 111. After that, this is we write the octal equivalent of each of these 3-bit binary sequences. So the first is 111, which in octal is 7, again 111 is 7, again 111 is equal to 7 in octal, 010 is equal to 2, and 110 is equal to 6. So if we have vice versa, we have to convert octal to hex. First convert the octal number into binary and then binary into hex. For example, if you have to convert 345, say this is the octal number and we have to convert it into hex. Say octal number is 345, and if we have to write this in binary, this we represent each digit in terms of 3 bits. 3 is written as 0111, 4 as 100, 5 as 101. So the binary equivalent of 345 is 111001001, and this binary is to be converted into hex. So we will start from right and make groups of 4 bits. So the first group will be 0101, which in hex is equal to 5, and the next group will be 1110, which in hex is equal to E. So the octal hex equivalent will be E5. Thank you.